Well, we're back at the Science Cave, and we're going to take a look at the ancient shorelines. Really what we talked about a little bit earlier in class was transgressions and regressions. And to have a transgression or a regression, a transgression, of course, is when the sea level rises, and a regression is when it decreases. You got to have a sea level change. And here are some examples of why sea level will change. Plate tectonics. We know about the mid-ocean ridges, the widening and the shrinking of ocean basins. We looked at that earlier this year. We haven't looked at too much in glaciation and ice ages. Hopefully you did this in middle school. But as the ice sheets would melt, you would assume that the water levels would rise. And then apparent sea level change can be due to the uplift of land masses. And again, we're dealing with plate tectonics here. If the land mass rises, then the sea level is going to drop. These next couple slides are some slides talking about temperature from different glacial periods. And through these in here, take a look at these. Again, the more times we look at different types of data, the better off we are. And here's another one talking about this also. And of course, we always go back to the climate change, the amount of CO2 that is getting into the atmosphere. And you can see definitely through the Industrial Revolution. Also, you need to remember too that volcanic eruptions throw a whole bunch of CO2 into the atmosphere. Sediments that are deposited at different depths of the ocean are different. Really, we looked at these. The sandstones were, the beach environment. Then we said shale was a little bit farther out. And then limestone, which is actually ancient critters, the farthest out. Well, you may ask why, but a lot of it really has to do with the density of the object or the material that's in the water. Sand, as you would probably surmise, has a little greater density, so it would not get carried out from erosion off the land very far offshore. Shale, on the other hand, very, very tiny clay sediments, very, very tiny particles, they could get swept out farther into the water, they would stay in suspension longer, and they would get further from the land, again due to their density. Limestone, on the other hand, is really ancient sea critters from a reef, and you would not expect those to be on the shore. You would expect those to be farther out into the waters. We looked at Walther's law already. You will definitely have a question on looking at some facies, and we looked at three types of rock, the sandstone, the shale, and the limestone. Here's a diagram of some shoreline environment, and you can see the different rock down here, and again depending on if it was transgression or regression. Looks like we got some shale here, some type of sandstone in this area here. Here's some things we've also saw in class. Here we have a transgression where the water is increasing, so it would go into the shore more. And here it migrates seaward or goes out, which would be a regression. And you can take any of these layers of rock and then you can kind of determine, has the water risen or has the water levels receded? Here's the Grand Canyon again. We looked at that. We should probably take a look at that again because really the Grand Canyon is made up, once you get past the bedrock, the schist and the granite there, really it's made up of sandstone, shale, and limestone, and you can tell if the water has transgressed or regressed on there. Well, again, this is a fairly short video. Hopefully most of this is review for you. If not, again, as always, don't be afraid to ask the questions in class.